Mr. Moore's math class!
Get on the floor, everybody walk the dinosaur. Open the door, get on the floor, everybody walk the dinosaur.
Good afternoon, ladies and gentlemen, and thank you very much for tuning into Mr. Moore's online flip classroom. Now, I'm super excited to be teaching you today because we're going to learn all about how to factorise quadratic expressions by completing the square. And in fact, this is the very last method that we need to cover in order to be able to factorise quadratic expressions correctly. Because, I mean, we've already learned how to factorise quadratic expressions with two terms. We've already learned how to factorise quadratic expressions with four terms. We've learned how to factorise quadratic expressions with three terms but no value for a. And we've learned how to factorise quadratic expressions with three terms and a value for a. So what we need to learn now is how to factorise quadratic expressions by completing the square. And who better to explain how to factorise these expressions by completing the square than the biggest square I know, Jerry. So let's check out what he's got to say.
Thanks, Tom. The square now feels complete. Now we need to use the method of completing the square when we have three terms. No value for a out of front of x squared. Note you may have to take this out as a common factor. No factors of c that add to b. Now, let's use this in a worked example, shall we?
Well, thank you, Jerry. Alright, now let's have a look at how to factorise quadratic expressions by completing the square where our b value is actually even. Let's check it out.
So we're going to have a look at how to factorise quadratic expressions by completing the square. But first of all, let's have a look at why we actually do this, and more to the point, when it's actually appropriate to do this. So in order to factorise by completing the square, we must have a quadratic expression with three terms, and it is in the form x squared plus bx plus c, that is, there's no value for a, or in other words it's 1, and no factors of c add together to get b. That is, when you go through and find the factors of c here, and you add them together, you cannot actually get the answer of b. And here are the 5 steps that you need to follow when factorising by completing the square. And if you have a look down here, I'm going to use the quadratic expression x squared plus 6x minus 1 to demonstrate these. Step 1. Look for any common factors and take these out. So if we come down here to our worked example, are there any common factors between x squared, 6x and negative 1? No, there's not. So from here what we need to do is just double check that we have a quadratic expression with three terms. Okay, so we've got 1, 2 and 3 terms, so that is actually correct. This is in the form x squared plus bx plus c. That is, there's no value for a. Okay, so yeah, you can see there's no value for a. And we've got three terms, so we're all good there. And are there no factors of c that add together to get b? Let's have a look at the factors of c being negative 1. So are there any factors of negative 1 that get b? Well, the factors of negative 1 are negative 1 and 1. And do these add together to get 6? Well, no, they don't. So we can actually factorise by completing the square. So we're actually going to do step 2 and step 3 in the same line of working out. So step 2 says halve and square the x coefficient, and step 3 says add and subtract this new term. So let's go through and do that now. Okay, so we're going to halve and square this x coefficient, and we're going to add and subtract this new term. So if we have a look at what I'm writing in red here, what we do is go plus 6 over 2 squared minus 6 over 2 squared. And then we finish it off with the minus 1 at the end. So what you can see here that I'm doing is I'm halving and squaring the x coefficient. That is, I'm going 6 divided by 2 because the coefficient of x is 6. So 6 divided by 2 is halving it, then I'm squaring it, and then what I'm doing is I'm adding and subtracting this new term. So what you can see here is I add 6 over 2 squared, and then when I minus 6 over 2 squared, what I'm essentially doing is nothing. But I've put in two new terms here because I'm basically trying to rig it for the next line of working out. So I haven't actually changed the equation as such, but I have in terms of being able to rig it for the next line. So let's simplify this a little bit now. So you get equals x squared plus 6x plus, in brackets, 3 squared minus 3 squared, because 6 divided by 2 is 3, minus 1. So now that we've simplified 6 over 2 in the brackets, it brings us to our fourth step, step 4, which says factorise by applying the perfect squares to the first three terms. So what I mean by that is we're actually going to factorise these first three terms here. And to do that, the easiest way to do it is you just circle the x, circle whatever sign's out the front of your b value, circle whatever's in the first bracket, and circle the squared. And you essentially just rewrite this information as bracket, x comes down here, whatever this sign is comes down here, so being a plus, and the 3 comes down here, so being x plus 3, and you've got your squared up here. Right, so I've actually factorised x squared plus 6x plus 3 squared, and of course 3 squared is 9. So imagine I've got x squared plus 6x plus 9, I've actually factorised it, and I've got x plus 3 squared here. So if I actually expanded this, I would get x squared plus 6x plus 9. And then I've still got my minus 3 squared being 9, minus 1 outside. And step 5 says factorise by applying a squared minus b squared is equal to a plus b in brackets multiplied by a minus b. Right, well we do this by saying let x plus 3 equal smiley face, just as we did in the last lesson. So that means instead of writing x plus 3, I can now write smiley face in brackets squared, and negative 9 minus 1 is negative 10. Alright, now you can see the two terms, so what I can actually do is rewrite it out as equals smiley face squared minus the square root of 10 squared. And of course, this here is our a value, and this here is our b value. So let's go through and substitute it into this formula that you can see up here. So we are going to get this here is equal to smiley face plus root 10 and smiley face minus root 10. Substituting back in for smiley face now, you're going to get this here is equal to x plus 3 in brackets plus root 10 and in brackets x plus 3 minus root 10. And when I expand the brackets of x plus 3, you're going to get this here is equal to x plus 3 plus root 10 and x plus 3 minus root 10. And that's how you factorise by completing the square. Okay, so now it's time once again for you guys to press pause and attempt to factorise the following. That is x squared minus 8x minus 5. Of course, once you're done, press play and check your answers out against mine. Alright, so the first step, as you can see up here, says look for any common factors and take these out. So are there any common factors between x squared, negative 8x and negative 5? Well, no, there's not. Okay, so now what we need to do is to double check which method's the most appropriate one to use, because obviously we know that completing the square method is quite long, so if there's another way to do it, we'd much rather do that way because it's faster. So to see if it's appropriate to factorise by using the completing the square method, what we need to do is look for the factors of c, so that's negative 5 and 1, and see if these add to b. Well, negative 5 plus 1, no, they actually won't add to negative 8. Right, so now that we know that it's appropriate to complete the square, what we need to do is look at step 2 and 3 together, and we're going to halve and square the x coefficient. So we look at the x coefficient being 8, or it's normally negative 8, but in this case you just take the number out the front, not the sign. So what you're going to do is go halve and square, so 8 divided by 2 is half, and then we square it. Then what we're going to do is add and subtract this new term so you can see the plus and the minus. Remembering that will keep it all being equal, but what we're doing is we're rigging it to set it up for the next step. Now 8 divided by 2 is 4, so that's just been simplified here. Now in order for the next step, what we're going to do is we're going to factorise the first three terms by applying the perfect squares method. So if we have a look at that, to factorise the first three terms, we're going to go x, we take the sign out the front of the b value, and then we take whatever's in the brackets, and obviously the squared. And we're going to bring that down here, so you now get x, the minus part comes down here, and the 4 comes here as well, and the square goes outside the brackets. So these first three terms factorised would actually be x minus 4 in brackets squared. And of course, I'll write that again down here, x minus 4 in brackets squared, and the negative 16 minus 5 gets you negative 21. So now what I'm going to do is I'm going to let x minus 4 equal smiley face in order to make it look like two terms. And so you've got smiley face squared minus root 21 squared, where smiley face will be a value and root 21 will be your b value. So substituting into the formula now for difference of perfect squares, you're going to get a squared minus b squared is equal to a plus b multiplied by a minus b that you can see at the top here. So smiley face being a plus b being root 21 multiplied by smiley face being a again minus root 21. And smiley face of course was equal to x minus 4, so we substitute that in now. X minus 4 plus root 21 and x minus 4 minus root 21. Taking out the brackets now gets you x minus 4 plus root 21 multiplied by x minus 4 minus root 21.
Alright, so now that we've learned how to factorise quadratic expressions by completing the square with an even value for b, let's have a look what happens if our b value is odd. Let's check it out.
Alright, so it's time for another worked example now. In this case it's going to be a little bit harder because in the previous case this one here was an even number and it made our working out a little bit easier. As you'll see in a second, by having an odd number this is going to make our working out that little bit harder and take that little bit longer. So the following question says factorise the following. x squared minus 9x plus 2. Alright, like always, what we need to do is first of all look for any common factors and take these out. Well, are there any common factors between x squared, negative 9x, positive 2? There's not. So let's have a look now to see if we should factorise by completing the square. Well, first of all, does it have three terms? Well, 1, 2, 3. Yes, it does. Is it in the form x squared plus bx plus c? That is, there's no value of a. Alright, well yes, it is in the form x squared plus bx plus c. That is, there's no value a at the front. And of course, are there any factors of c that add together to get b? Well, let's have a look at the factors of c. That's going to be 2 and 1. And can we in any way make these add together to get negative 9? No, we can't. So that means we must factorise by completing the square. Now takes us on to step 2 and 3, where we need to halve and square the x coefficient and then add and subtract this new term. So let's do that. We're going to go equals x squared minus 9x. Now we're going to halve and square it, so we go in a different colour, plus 9 on 2 squared minus 9 on 2 squared, and then we go plus 2 at the end. So as you can see, I've halved and squared the x coefficient, and then I've added and subtracted it. Now this is where it's going to get a little bit more interesting, because what you can see here is 9 over 2 is equal to 4.5, or 4.5. Alright, so what we're actually going to do is we're going to keep it as 9 over 2, and that's going to make our working out that little bit harder. So let's go through and do that. Because I can't actually simplify this, I'm just going to go ahead and factorise these first three terms as they are. So let's circle the x, the sign out the front of the b value, whatever's inside the brackets, and the squared, because that's how I'm going to factorise. And that there is going to be equal to x comes down here, the minus follows it, the 9 over 2, and then the squared. Right, and that's going to leave me with minus bracket 9 over 2 squared plus 2. The next step now is to simplify the bit outside the bracket, so you get x minus 9 over 2 squared minus 9 squared over 2 squared, so that's going to become 81 over 4 plus 2. Right, now what we need to do is we need to add these terms together, so let's rewrite it out with a common denominator. So you get this here is equal to x minus 9 over 2 squared minus 81 over 4 plus, now the number on the bottom here has to be 4, and what divided by 4 gets us 2? Well, that's going to be 8. 8 divided by 4 gets us 2, and that's the answer there. Just double check it always whenever you're converting between fractions. Alright, and combining the last two terms now, you get x minus 9 over 2 squared minus 81 plus 8, well that becomes 73 over 4. And now what we need to do is we need to let x minus 9 over 2 equal smiley face. So what that gets us is smiley face squared minus, in brackets, square root of 73 over 4 squared. And in fact what I can do here is write smiley face squared minus, now the square root of 73 we don't know, so we just leave it as square root of 73, but we can actually square root 4, which gets us 2 squared. Alright, where this is our a and this is our b value. So bring it up here now, and we're going to substitute our a and our b value into the formula that you can see in step 5, that is a squared minus b squared is equal to a plus b, a minus b. So let's do that. This here is going to be equal to smiley face plus root 73 on 2 and smiley face minus root 73 on 2. Let's go through and substitute back in x minus 9 on 2 for smiley face again. So you get x minus 9 on 2 plus root 73 on 2 multiplied by x minus 9 on 2 minus root 73 on 2. And expand the brackets again, so you get x minus 9 on 2 plus root 73 on 2 and x minus 9 on 2 minus root 73 on 2. And of course we can actually combine these two terms in each of the brackets, that is the minus 9 on 2 plus root 73 on 2 and the minus 9 on 2 minus root 73 on 2, because it's got a common denominator of 2. So let's go through and do that now. This therefore gets us x minus 9 plus root 73 on 2 and x minus 9 minus root 73 on 2. And there you have it, that's been factorised.